All right, welcome to week 7 online video lesson, and we're going to start the Orange Book. We're actually going to start chapter 5 on bivariate statistics. So I'm going to just start by giving you a data set. Take a couple of seconds and read through it. If you, again, I probably will continue to talk, but if I tell you to take a couple of seconds, read through it, press pause, read through it, and then go back to it. Otherwise, the video ends up being like 30, 45 minutes long, and my goal is to keep it to about 20 minutes. So just looking through the data, what do you think? So we're looking at the age and distance thrown, and it's recorded for each athlete, athletes A through L. Reading through the questions, do you think the distance an athlete can throw is related to a person's age? What happens to the distance thrown as the age of the athlete increases? How could you graph the data to more clearly see the relationship between the variables? And how can we measure the relationship between the variables? So that's where we're heading in this chapter. Is we're going to be starting to look at data in 2 ways based on the same individual. So athlete A is 12 years old and they threw the discus 20 meters. Whereas athlete B is 16 and they threw the discus 35 meters. So thinking about that, we can now start to create a graph to represent this data. And these graphs you guys have used before. In fact, this is what that graph might actually look like. So I use Desmos. If you use the table feature in Desmos, you can actually plot the points. So we would be able to see that this point here, as I started the iPad again, that's why the pen has to be started every time. So we can see that data value H, individual H, athlete H, is this data value right here. So they are 10 years old and they threw the discus a total of 15 meters. Whereas right here at age 13 is both athlete E and athlete L. So athlete E threw at 27 meters and athlete L threw at 20 meters. So we can see this value, we can see these data from here. So thinking about this, what do we think? What do we think about the data itself? What do we notice? Do you think this trend goes on forever and ever? So all great questions. So what we're doing is we're moving on to discuss this bivariate data which has 2 variables recorded for each individual. Most of the time, we'll not be able to determine an exact relationship between the variables. Our job will be to find the model which best fits the data, and then we're going to measure how strong the relationship between the variables is. So just thinking about this idea of discus throwing, we would anticipate that the distance thrown will be dependent upon the age of the athlete. So the older an athlete is, the further they can throw the discus. That would make sense. You guys could throw a discus at age 17, 18, probably further than my 9-year-old son. 1, physical maturity, muscles. You guys are definitely that. Probably also teachability. You could be taught the process to throw a discus. He may just go out and wing it. But all of these things are factors in that idea of who can throw a discus further. All right, so what we're going to be looking at in this chapter is we're going to be looking at the association between numerical variables. So one of the best ways to start this idea of what does our data look like is to use that idea of a scatter plot. That's what we've called it forever and ever. Your book will refer to it as a scatter diagram. But a scatter plot is a great way to start identifying the relationship between 2 variables that can be found on each individual. Example, what you end up starting to see is that if we have our y-axis and our x-axis, traditionally on our x-axis, we will graph the independent variable. And on the y-axis, we will graph our dependent variable. We can also refer to these as explanatory variables. And response variable. So the x variable or the independent variable explains something about the response variable or the dependent variable. So the independent one is the one that we can change. The dependent one is the one that we get as an outcome based on changes in the independent variable. That also being said, the response variable is a direct result of something that is an explanatory variable. Now, we're going to continue to talk about that in a little bit later. Not everything has an explanatory and response relationship. Sometimes it's just an independent and dependent relationship, but we're going to talk about those ideas of what that relationship looks like. So, in our analysis of the scatter plot, we're going to talk about correlation. And what correlation does is it refers to the relationship or association between two numerical variables. Okay? So when we talk about the correlation, we are going to talk about 5 different things with regards to correlation and this relationship or association between the two variables. So when we look at these, we're going to talk about the direction, we're going to talk about linearity, we're going to talk about the strength, we'll talk about outliers, and last but not least, we're going to talk about causation. So correlation is the relationship and association between the two variables, and then within correlation, we're going to look at those additional 5 things. So we're going to look at the direction first. So this one, the top one, has a direction that is positive because it is rising from left to right. So again, that kind of goes along with that idea of what slope is. Directionality is the idea of, is your slope positive or is your slope negative? What do the data appear to do? So a positive correlation, as x increases or as the independent variable increases, the dependent variable will also increase, which then means that the next one is going to have a negative direction. It is going down, negative spelling. So it is falling from left to right. So if it's falling from left to right, it has a negative relationship, and that's what we're looking at with regards to that. So as x increases, y is decreasing. So this last one, we look at the trend. So in the first one, the trend is going up, so it is a positive. The trend is going down in the second one, so it appears to be negative. And this third one, there doesn't actually appear to be a trend. So we say on this one that there is no relationship. So we actually look at this one and we say no correlation. It really doesn't even have a direction because there's no relationship between those variables there. And we can clearly see that because those values or those data values are very, very randomly scattered over the graph. All right, so the next thing we're going to look at is we're going to actually look at the linearity of the graph. So if a trend exists, we look to see if it follows a linear trend or it does not follow a linear trend. So this one appears to follow a linear trend. This one appears to be nonlinear. Now, as you continue in statistics, you can actually look at these nonlinear trends and you can actually work with those. We're going to start this unit and we're going to strictly be looking at linear trends versus linear trends. Okay, so we'll talk about the linearity based on this as well. So within correlation, we're going to talk about the direction. We're going to talk about whether or not it's linear or nonlinear. This one appears to be linear. Then we're also going to talk about the strength of the scatter plots. So very clearly you can see we've got 3 different levels of strength. We'll talk about things that are what are called strong relationships versus moderate relationships or moderate trend lines versus what we would say is weak. So if the dots or the data points are very widely spread apart, they appear to have a linear relationship, they appear to have a slightly positive relationship. But what happens in this weak category is that they're widely spread, so we would say that they're weak. If there's a relatively close patterning, we would say that they're moderate. If they're very, very close, meaning they all appear to be on that trend line, then what we say is that they are strong. The top line of these set of graphs, they're all going up, so we would say that they are all what? Yep, you nailed it. We would say that all of these top ones are positive. We would say all of the ones on the bottom, yep, they are negative. So we could say it has a positive, strong, or a strong positive relationship, linear relationship. We could say it has a moderate negative relationship, linear relationship. The weak ones, we can say that they're linear. They definitely appear to be linear. There's definitely, in the top one, it definitely appears to be trending upwards. So it would be a weak linear positive relationship or a weak negative linear positive linear relationship. So we have talked so far about correlation. Correlation is the relationship or the association. We'll talk about the direction, positive trend, negative trend. We'll talk about it being linear or not. And then we're going to talk about the strength of that relationship. Now, also within those relationships, things that we need to identify or things that we need to look at is we need to look at the presence of outliers. Now, an outlier is an isolated point or points that do not follow the trend line. So if we have a set of data and we graph it on a scatter plot, we can draw a trend line that kind of represents the data. We're going to talk about specific trend lines in upcoming sections, but we're going to talk about that trend line, and we see that this trend line is very clearly going down, okay? Now, there are 2 points that don't seem to fit in with the other data values. Those 2 points are this one here. I'm going to highlight them both. And that one there. They both don't fit the overall data. However, only one of them is an outlier, and that's this one here. This one is your outlier. And now I know it's already written there. I'm going to write it again. That one's the outlier because it doesn't fit the overall trend. The one on the far right, this one, isn't an outlier because it fits the trend of the data. It appears to be going down. As X increases, the data is also, there's a fly again, the data is also decreasing as well, that Y value. All right, fly, come back and die. Oh, I'm still recording. Great. So yeah, come back fly. I'm gonna kill you. I've got my fly swatter. Question, hopefully there's no questions on this so far. So we're gonna talk about the outliers. Now, this is where correlation and this is where statistics gets fun because all of this stuff is pretty easy to actually do. Sometimes strong and moderate, we may argue one way or another, whether or not we think about it. Sometimes we'll talk about something, whether the outlier truly is an outlier versus maybe is not an outlier. Positive and negative trends, those are pretty easy to identify. But the challenge becomes is when we start talking about causality or causation. So I actually pulled this data up and I found that sunlight in Colorado inversely or negatively correlates with military defense spending in the UK. Awesome. And if I plotted my data is right here. There you can see sunlight in Colorado and UK military defense spending. And so we've got our data values. So the individuals are the years. So the individual was the year 2008, 2009, 2010. Our data values are the kilojoules per square mile from the sunlight in Colorado. And we can see also that we're looking at UK defense spending in millions of dollars. So I'm saying that these are my X values. That's my independent variable. And I've also plotted my defense spending on my y-axis as my dependent variable. So there's my data in a nice, lovely graph on Desmos again. We can see those points. If I wanted to, I could draw a trend line through them. It appears that they are going down. So we would say it is a negative trend. I don't know. What do you think? Is it moderate or strong? I might say it's kind of moderate. So we've got a negative moderate correlation between the amounts of sunlight in Colorado and UK military defense spending. Awesome. So the more sun we have in Colorado, the less money the UK spends in military defense, right? Exactly. PK, that makes absolutely no sense. Why would sunlight in Colorado have any impact on military defense spending in the UK? That's exactly what we're talking about in this one. So what we get to, and the big line that you'll see quoted everywhere, and I think it's really important for us to remember, is that the following: correlation does, missed it, not imply causation. Just because there is a correlation between two variables does not imply that one causes the other to occur, happen, get bigger, get smaller. Okay, just because there's a relationship between two variables doesn't mean that there is causation between the two variables. There's clearly a relationship between the amounts of sunlight in Colorado and the UK military defense spending. However, the amount of sun that we get in Colorado does not cause the UK military defense spending to go down. So an increase in sunlight does not cause that decrease to go down. So where this is actually kind of cool, and it actually came out, and as I researched this, is as we started this idea of, or it's not really started, as COVID-19 and the coronavirus became more and more prevalent within the world around us, there were a lot of conspiracy theories with regards to COVID and what was actually causing COVID. And actually one of the conspiracy theories was, let me fix this, was that 5G, this move to 5G across the world was affecting COVID. So that social media mentions actually talked about this, that one, there were a lot of social media mentions back. This actually data, and this website, I'll link to it later and show you guys, is that Bill Gates created the coronavirus. There were a lot of social media mentions that 5G caused COVID-19. There were quite a few other ones there, that George Soros created the virus, that COVID-19 is actually a bioweapon. But there were a lot of conspiracy theories. Quite a few of them have been debunked, and actually that's all I found on the 5G and COVID is kind of the debunking of them. But the idea is that there's a relationship between 5G and COVID, but it's not that 5G affects or increases COVID. COVID was very prevalent and is very prevalent still in large cities, in highly densely populated areas. And if you look at 5G, as 5G has expanded, 5G is expanded in large cities, highly populated, population dense areas. If you had an island with maybe only 2 people living on it, probably very low COVID numbers or 0, but you're also not going to build a 5G tower on that island that is not very populated with all of 2 people. So let's take what we actually talked about. This was our opening problem. I want us to describe this scatter plot. And I'm actually going to pause there. I'm actually not going to describe it. I am going to put this into another website. It's called Edpuzzle. And I'm going to ask this question of you. I want you to describe this scatter plot. I want you to think about the correlation. I want you to think about the 5 ideas of directionality, linearity, strength. I want you to talk about potential outliers, and then this idea of causation and within correlation. So I'm going to ask you to describe that kind of as a part of the exit ticket with this video. Thanks for focusing and paying attention. I'm going to go kill that fly.